So yeah, my solution basically is exactly what the last team just described as the simple model. But I forgot the slide. Let me introduce myself. So I'm Yusef. I'm a data scientist at Adaminta. I'm originally from London, but I've been based in the Netherlands for nearly 2 years now. I've got a master's in applied stats, and I recently became Kaggle master, which on this call feels a bit like that meme of the guy celebrating in third place or something, but there we are. So yeah, let's get into my solution. So it's very straightforward, and it was basically just a meme prompt. And the way I yeah did this is similar to what other people did. So like a greedy search on the tokens, based on the data I have, and then like sort of iterative refinement, because I mean obviously you use like a sentence embedding, so it doesn't really make sense to go one token at a time, because sort of adding, you end up getting stuck basically, because of well, because it's embedding the meaning rather than the individual words. One thing I actually wasn't sure about was this token Lucarea, which I didn't think it was analogous to the end of string token that that was mentioned in some of the other discussions. Like if you actually look up what it means, it's a Romanian word and sort of means like a lot of different things. So it means work, it means text, it means paper. And I thought in the context of sort of what you're trying to predict, like it tended to be this word that was really kind of sort of loosely defined, but agreed with everything that you were kind of trying to predict in that sense. And yeah, what's sort of interesting is that it's I guess it's in the tokenizer because it's a relic of when T5 originally came out. And I think the two use cases were translate, or one of the two use cases were translate English to German and translate English to Romanian. And then when ST5 was trained, it was trained on English only text. So it's sort of yeah, somehow kept its meaning based on that similarity. But yeah, anyway, yeah, what I ended up with was this meme prompt, and this meme prompt alone, I think this alone would have been second on the public leaderboard, and then I added Mistral at the end, for it sort of yeah ended up giving me a little bit of a boost, sort of similar to what Philip had said in terms of if you sort of think of this as the kind of intercept of the regression, and then the Mistral being the sort of smallest adjustment you could make. But yeah. So the way I did this was, again, similar to the other team. So I used Gemini for my prompt. I found one of the tricky things about this competition is that there was a lot of data that people generated, but a lot of it was a bit rubbish. And I found, especially the stuff that GPT-4 generated was sort of quite robotic. And I mean, to be honest, a bit crap, right? Like, rewrite this quote as a quote to be quoted, right? That kind of thing. I think we all saw that. It seemed to love the word whimsical and put that in everything. It seemed to, ask about writing stuff in the style of Hemingway, right? And you dig into the T5 tokenizer. T5 tokenizer, it does have Shakespeare. It doesn't have Hemingway, right? Like so. I found using Gemini to be best here, and the rewrites. And actually, I ended up going with Mistral, but I also toyed with Gemma. I thought the original Gemma and Gemma 1.1 had huge differences. I thought 1.1 was performed a lot better, and actually I had similar results when tuning. And in the end, I the last thing I was sort of struggling on was whether to use Mistral or Gemma for the kind of final bit at the end. But in my submissions, they both did relatively well. So yeah, the way I sort of tried to get this was I actually tried to, I thought, well, what happens if I give a sentence in Latin or French, and then ended up digging into the T5 tokenizer to sort of see how it was decomposed. Yeah, as I say, it was initially generated by hard search on the next best token that maximized similarity, but then yeah, sort of iteratively refine them individually by going back. And I also did something similar to the team that spoke just before me, and I got like I think I generated. I didn't have a massive data set. I think I had about 5,000, and yeah, effectively took the scores that I knew were on the public leaderboard, took the scores that were in the public solutions, and effectively used a few different ways to try and generate a decent data set of about 1,000. So yeah, kind of top down, bottom up, and kind of genetic algorithms, these kinds of things, right? Like given the sum of the similarities that I expected, how far did it deviate from the individual ones, and penalize where there were massive differences. So that similar to what the last team said, that made a huge difference. Because as I say, the public leaderboard or the public data sets were not very good. Yeah, that's exactly what I just said. I probably should have been on this slide when I spoke over it, but yeah, that's basically it. And then I added Mistral at the end because sort of what I found was, and I think a lot of people had this issue, was that ST5 was sort of, if you were one word off on a relatively short sentence, even if the meaning was similar, you get penalized very heavily. But if you had that same phrase and appended it to a meme prompt, it ended up doing a little bit better. And that was the sort of reason I went with Mistral, and I prepended it with the sort of modify this text by making it. I tested a few different variations, but these were all sort of in the T5 tokenizer. They scored quite well by themselves. And yeah, one of the other things that I spotted was the TensorFlow Hub ST5 and the PyTorch one had slightly different variations. So obviously you don't have the special characters. There are extra IDs that are also in the PyTorch one, which actually did quite well. I'm not really sure why, but they did quite well. And the TensorFlow one was capped at I think it was 128 tokens. It might have been 100. So this is something like 90 tokens, and then I had about 10 to play with in terms of getting somewhere a little bit closer to the final solution. This I think is the last slide. So as I say, it was very first. So yeah, I learned a few Romanian words because that's in the tokenizer. So that's a lot of fun. The adversarial method, so obviously to try and predict the embedding, I think give me a little bit of a boost. And yeah, trying to look at embedding similarities and trying to model that, it did give me a little bit of a boost, and I did try and kind of append kind of a hard search on the token on the mean prompt through this method, and I think that actually did score my best, but on the private, but it wasn't the solution. So that did help, but obviously I think team one said this at the start, you were sort of heavily constrained by the size. And I thought the competition ended up sort of being about the metric, which for me, it was my first NLP competition. So in a way, that's great because I would have done really badly otherwise. But yeah, it's sort of what I said. Like it actually is quite a good model for longer texts, right? So given a meme prompt and something appended that kind of pushes the embedding towards the general direction, that helped. But when you don't have that meme prompt and you have a very small short sentence, then getting rid of that penalized it quite heavily. And yeah, overall, it was a super interesting competition. I really enjoyed it. So thank you very much. I think that's it.